Good evening, and I welcome you, students. We are coming to the last part of the sound chapter, very important. You have seen how the sound waves propagates from a source to the receiver end, how compressions and rarefactions are moving, propagating. And we have also defined some of the characteristics of the sound waves: wavelength, frequency, speed of the sound waves, time period. You have seen the sound travels with the different speeds in different material media.
Yes, sir.
So as the media will change, the speed of the sound also changes. And there are certain interesting phenomena and applications which are associated with the sounds. If you ever go to a very tall building and shout, or you go towards the mountains and shout, what do you experience? What do you experience? Do you experience another sound coming back after some seconds or some period of time?
Yes, sir.
So what is happening that you have tall buildings or a mountain, you are shouting or clapping, and we will hear some sound again a little later. What the sound is coming from? You have, supposing, mountains, tall buildings, and you shout, and you will hear, students, a sound after a few seconds. What is this? Why do we hear back the sound? What is this known as? So sound is repeated because you have been told the sound waves are reflected. Sound undergoes reflection. If they are reflected back, what will happen? Sound reaching, striking some surface, and then coming back, reflecting back. What can happen? And that is what we talk of echo. तो हमें क्या सुनाई देती है? गूंज सुनाई देती है, echo सुनाई देती है. So students, we are saying echo is a sound that is repeated because sound waves are reflected back. Question: why do we hear echo? What is the answer you are giving?
Sir, because of reflection of the sound.
Sound waves are reflected back. Sound waves are reflected back. And once they are reflected back, it will take some time to reach you, students. That's why sound is heard a little later. They can bounce off smooth, hard objects in the same way as a rubber ball bounces off the ground. Although direction of the sound changes, the echo sounds the same as the original sound. The sound same, the direction can change because you have already studied the laws of reflection. So this is our definition. Another thing I can say, the repetition of sound caused by reflection of sound waves is called an echo. We can hear when there is a time gap of 0.1 second. This is important point. If I am sitting in my room, I am giving a lecture, I am not able to listen my echo. Not listening my echo. But if the building is very tall, then we can hear the echo when there is a time gap of 0.1 second. In original sound, an echo reflected back. When the time gap will be 0.1 second, then we will be able to hear. Echo is produced when sound reflected from hard surface, brick, wall, mountain, or soft tends to absorb the sound. Okay. 0.1 second. Now, what we are trying to say, The speed of sound in air, if I assume around 20 degrees Celsius, what we said speed of sound in air is 344 meter per second. The speed of sound, what is the speed of the sound velocity? This is my distance by time, S by T. This is 344 meter per second. 344 meter per second. When the sound takes 1 second to reach the wall, if it takes 1 second, okay, to reach the wall, this is the wall. The sound goes, it takes 1 second to reach the wall, student. Then if it will come back, what will be that time? 1 second and 1 second.
2 seconds.
2 seconds. So if we are going to hear the echo, students, which we have shouted, it will return to us in after 2 seconds. The return is 1 plus 1, 2 seconds. If two sounds reach our ears with an interval of 0.1 second. Now, if the two sounds reach our ear within 0.1 second, then we cannot hear them as separate sound. They appear just one sound. If 0.1 second is the gap, okay, reflected, and that is less than within interval of 0.1 second, then we will not be able to hear this echo. That will appear one sound. The human ear can hear two sounds separately if there is a time interval of 0.1 second between the two sounds. So if the time becomes 0.1 more than that, then only it will be possible to hear. Okay? If it comes before that, then it will appear to be just same sound. The minimum distance from sound reflecting surface which is necessary to hear an echo can be calculated. What will be the minimum distance? 344 distance by time. That we are saying the minimum distance is, minimum time is 0.1 second. If it is less than that, then this sound appears to be the same, only one. That will mean how much distance? Put the values, 344 by distance by 0.1. Distance is coming how much? 34.4 meter. What we are saying, student? This and this distance total, going and coming back, how much?
34.4 meter.
If this goes from A to B and this is from B to A back, then AB plus BA is 34.4 meter. And then what will be the distance traveled by sound in 0.1 second is how much? In 0.1 second, the distance traveled is how much? 34.4 meter. And distance from sound reflecting surface to hear echo, then what will be the distance for hearing the echo going and coming back? What is the distance? Half of this. What will be half of this? 17.2 meter. The distance from a sound reflecting surface to hear an echo is then 17.2 meter. Where the speed of the sound is 344 meter per second. In order to hear an echo of our side, we should have at least 17.2 meters away from the sound reflecting surface like a wall. So minimum distance, how much is coming?
17.2 meter.
2 meter. If that distance is not there, we will not be hear the echo. That is why we are saying tall buildings, mountains, the distance becomes more than 17.2 meters, then we can experience the reflected sound. That is the echo. All right. If there are several reflecting surfaces, then multiple reflections of sound takes place and hence several echoes may be heard. कई बार आवाजें गूंजती हैं, एक के बाद एक ऐसे गूंजती हैं आवाजें. इसका मतलब क्या है? मल्टीपल रिफ्लेक्शंस. मल्टीपल रिफ्लेक्शंस. तो सेवरल इकोज में भी हर्ड. रोलिंग ऑफ थंडर इज, थंडर्स जो आप सुनते हैं, थंडर जो बिजली खड़कती है, खड़क खड़क, वो क्या होता है? मल्टीपल रिफ्लेक्शंस होते हैं. साउंड ऑफ थंडर फ्रॉम नंबर ऑफ रिफ्लेक्टिंग सरफेस सच एज क्लाउड एंड. तो ये नंबर ऑफ रिफ्लेक्टिंग सरफेसेस से जो आती हैं वो रोलिंग ऑफ थंडर्स, रोलिंग ऑफ थंडर्स होती है. They are examples of multiple reflections. Another important point is coming, students. What is reverberation? If a sound is made in a big hall, sometimes you have seen big halls, students. The sound waves are reflected repeatedly from walls, ceilings, and floor of the hall and produces many echoes. What happens then? Many echoes are being produced because there are many reflecting surfaces. The echo time is so short that many echoes overlap with original sound. So echo का time इतना short है कि they overlap with the original sound. Number 1 point. Number 2, in a big hall, excessive reverberation is highly undesirable. जो बहुत सारे bigger halls हैं, if excessive reverberation, if large number of multiple echoes will be produced, then this is undesirable. If reverberation is too long, then sound becomes blurred, distorted, and confusing due to overlapping of different sounds. What will happen? These reflected sounds or echoes, they will overlap, and then you won't be able to listen the proper sound. Sound will become blurred, distorted, and confusing. Then what we do? Modern concert halls are designed for optimum amount of reverberation. The reverberation should be optimum. The excessive reverberation is reduced. How do we reduce the excessive reverberation in big halls? Big halls. What do they do? Carpets on the floors. You have seen in cinema halls, there is a carpet on the floor.
Yes, sir.
Carpet on the floors. Heavy curtains on doors. They put heavy curtains, you have seen. And windows. Roof and walls are covered by sound absorbent material like compressed fiber board, rough plasters. And you can watch this now. Earlier, you have not paid much attention. You can see why there are carpets. Sometimes you will feel like you are going to a theater and there's a carpet on the floor. Heavy curtains and roof and walls are covered by sound absorbent material. Because if large number of repeated echoes will be there, then the sound will become blurred, confusing, and distorted. So there has to be an optimum amount of reverberation. So many echoes will be produced, and when they will overlap, you will not be able to listen to the original sound. That is the problem. So this is called reverberation. Question has been asked, what is reverberation and why the big concert halls, they have carpet on the floors, heavy curtains, and absorbent materials, fiberboard and plasters are there on the walls and roofs, because there will be multiple reflections of sound which is being produced. There are some important uses of multiple reflection of sound. Another question, what are the uses of multiple reflection of sound? What are uses of multiple reflection of sound? You have seen megaphones, bulb
Yes, sir.
horns, musical instruments, trumpets, shinai are all directed to send sound in a particular direction without spreading them all around. In all these, a tube followed by a conical opening reflecting sound waves repeatedly so that most of the sound waves produced go in the forward direction. What is happening? यहाँ पे क्या हो रहा है आप देख रहे हैं मेगाफोन. The shape you are seeing like this. So sound in a particular direction without spreading all around. तो tube है followed by a conical opening. Tube followed by a conical opening reflects sound waves repeatedly. Reflects sound wave repeatedly. Most of the sound wave produced goes in the forward direction. तो ये सारी sound waves कहाँ जा रही हैं? Most of the sound waves produced go in the forward direction. ये हॉर्न आपने देखा कहीं जगह? पहले ये हॉर्न यूज हो रहे थे, इलेक्ट्रिकल नहीं थे, तो ये हॉर्न बजा रहे थे. अभी भी कहीं जगह यूज हो रहा है ये हॉर्न. Megaphone and a horn. This is other examples of multiple reflections. अब आपने स्टेथोस्कोप देखा. What is a stethoscope? It is used by doctors for listening the sound produced within the human body, mainly in the heart and the lungs. डॉक्टर लोग क्या यूज करते हैं इसको? क्या साउंड वो लिसन करते हैं? हार्ट एंड लंग्स का. कैसे पहुंचता है ये डॉक्टर के कान में? Sound reaches doctor's ear by multiple reflection of sound waves through the stethoscope tube. तो ये ट्यूब होती है स्टेथोस्कोप की, लंबी सी आपने देखी है ऐसे. तो मल्टीपल रिफ्लेक्शंस होते हैं जिससे कि ये साउंड पहुंच जाता है डॉक्टर के पास, as you can see. तो स्टेथोस्कोप भी यूज करते हैं. This is also example of multiple reflection. Stethoscope tube, ये मल्टीपल रिफ्लेक्शंस हो रहा है, देखिए साउंड वेव्स का. What is a soundboard? Soundboard क्या होता है? The ceiling of concert hall, conference hall, cinema halls are curved so that sound after reflection reaches all corners of the hall. तो ceiling, we should try to see the ceiling of a concert hall, conference. वो कैसी होती हैं? वो कर्व्ड होती हैं, दे आर कर्व्ड. उसका क्या रिजल्ट होगा? तो रिफ्लेक्शन विल टेक प्लेस and sound will be able to reach all the corners of the hall. A curved soundboard may be placed behind the stage so that sound after reflecting from soundboard spreads evenly across the width of the hall. तो ये कर्व्ड सीलिंग ऑफ द कॉन्फ्रेंस हॉल है, ये सीलिंग कर्व्ड है, ये साउंड जा रहा है, ये जा रहा है, ये जा रहा है, ये जा रहा है, इससे क्या हुआ, जो अब रिफ्लेक्ट हो रही है तो ये सब जगह पहुंच रहा है साउंड, देख रहे हैं यहाँ पे, ये यहाँ से रिफ्लेक्ट होगा, इधर जाला, दिस इज द रिफ्लेक्शन, दिस इज द रिफ्लेक्शन, इधर गया, ये रिफ्लेक्शन, इस तरह से ये सारे हॉल में स्प्रेड हो रहा अक्रॉस। तो साउंड बोर्ड स्प्रेड्स इवनली अक्रॉस द विड्थ ऑफ द हॉल आल्सो। तो ये जितने भी ऐसे हैं कंसर्ट हॉल, सिनेमा हॉल्स, उनमें ये यूज होता है। तो ये सोर्स ऑफ द साउंड है, ये देख रहे हैं साउंड बोर्ड, ये कर्व्ड है, तो ये क्या कर रहा है, ये सोर्स गई, ये रिफ्लेक्ट कर रहा है, sound is able to reach the entire width of the hall. Width of the hall. This is the source of the sound. This is the sound waves. ये sound wave जा रही हैं, sound waves, and you can see how this reflected, ये curved surface है तो ये parallel हो गई हैं, and they will go into the all across the hall. So soundboard is used. Why soundboard is used? Question. Why soundboard is used, ठीक है, in big hall. ये आंसर हमारे पास यहाँ पे लिखा है, already given the answer. Sometimes questions are put up, what is the range of hearing? You know there is a range of hearing, student. The range of frequency which our ears can catch is how much? 20 hertz to 20,000 hertz, mean 20 to 20 kilohertz. Sometimes it is not possible that if I written 20, that if I put 20, that you will be able to listen. Yeah, it's a range actually, student, in between 20 to 20 kilohertz. We are saying, student, it is a range. It's a range, student, which is called audible range. The sound which we can listen, audible sound, the sound of frequency lower than 20 hertz are called infrasonic. What is infrasonic? Less than 20 hertz. And we cannot hear them sound, that we will not be able to hear. Infrasonic sounds are produced by vibrating. Just a simple pendulum is vibrating. It will produce infrasonic sound, which our ears cannot hear. Whales produce करती हैं, elephant, rhinoceros commute of frequency as low as 5 hertz. तो ये जो कुछ animals हैं, they can commute frequency as low as 5 hertz. तो 20 से भी नीचे वाली जो earthquakes में होती हैं, they can catch.
Sir, your voice is lagging.
Some maybe network problem could be there. It may be okay in a short period of time. Some weather conditions sometimes are affecting. You can see, otherwise recorded video will be available, but I think it will become okay. अच्छा कोई बात नहीं. आ गया दोबारा से साउंड?
Yes, sir.
Okay. Network problems are there. Sometimes it is happening. So what are infrasonic sounds which are less than 20 hertz, and some animals can commute how much? 5 hertz, which are earthquake, etc. They record these signals and may become restless if earthquakes are coming. The sound of frequency higher than 20,000 hertz are called ultrasonic sounds. Ultrasonic sounds. So we also have ultrasonic sounds. What are those ultrasonic sounds? Greater than 20 kilohertz. They are ultrasonics. Dogs, bats, monkey, deer, cat can hear ultrasonic sound. Due to higher frequency, ultrasonic sound has much higher penetrating power than ordinary sound. The penetrating power is more because the frequency is higher. What is this frequency? Frequency means energy is higher. Higher energy sound, higher frequency. Ultrasounds. Then number 2 point, number 3. Some animal gets disturbed and start running here and there just before earthquake. Why it happens? Because before the main shock waves, the earthquake produce low frequency. Low frequency infrasonic sounds which some animals can hear and get. Some animals can hear infrasonic sounds. What are infrasonics? Less than
20 hertz.
Less than 20 hertz. So they can start behaving in a different way. They'll get disturbed. We cannot hear screams of a bat. What bat has got? What? Ultrasonic sound, which is much higher than 20 kilohertz. And we cannot hear the screams of a bat. Frequency is much higher than 20,000 hertz. Bats. Usually questions are asked on the applications of ultrasound because it's very, very important. Applications. High frequency waves. You see that in science, this is important. Science is based on application part more. Everything is application, how much we can apply. And low frequencies have applications, high frequencies have applications. Let us see what are the applications where we are using ultrasounds. You already know what is an ultrasound, Ultrasound is so important now. Ultrasounds are high frequency waves. What are ultrasounds? They are high frequency waves. They are able to travel along well-defined paths even in the presence of obstacles. When obstacles are there, still they can travel. Are used extensively in industries and for medical purposes. Very important. Ultrasounds. So high frequency waves. Ultrasounds are high frequency waves which can travel. They can travel even and the different uses of ultrasounds are in navigation, cleaning, medical field, crack detection in metals. Out of these, medical field has multiple application. Echocardiography, lithotripsy, ultrasonography. Medical science is using a lot of these ultrasounds. Let us see what are these. Ultrasound is generally used to clean parts located in hard to reach surfaces. Hard to reach surfaces. What are these hard to reach surfaces, students? For example, you have spiral tube. You have electronic components. That objects to be cleaned are placed in cleaning solution So objects to be cleaned are put in cleaning solutions. Ultrasonic waves are sent into the solution. Ultrasonic waves are sent into the solution. What will happen? Due to high frequency particles of dust, what particles are there? Particles of dust are there, or other grease, dirt. They are wherever they are attached, they will start getting detached. So particles of dirt, dust, grease will get detached. Detach हो जाएंगे, ठीक है, and drop into the solution. So objects get thoroughly cleaned. Objects are thoroughly contained. So cleaning की जाती है objects by using ultrasounds. What else use is there? Ultrasounds can be used to detect cracks and flaws in the metal blocks. Metallic components are generally used in metallic components कहाँ पे use करते हैं? Construction purpose के लिए. Metallic components are being used, student. ठीक है? Construction of big structures. Construction, big buildings आप बना रहे हैं, और bridges, machines. Whatever you are making for construction purposes, students, there could be cracks or holes inside the metal blocks. So if there are cracks and holes inside metal blocks, जो invisible है, which are invisible, ठीक है, from outside, and reduces the strength of the structure, ठीक है, of the structure. तो ये बहुत डेंजरस चीज है कि you are using certain metallic components for construction of big building, bridges, machines, but they may have certain cracks in between them which are not visible to you. What will happen? Then it will become weak when you will install it in a building or a bridge or a machine, because these are big buildings, big machines, big bridges, and then it can cause a serious damage. Hence, to detect that, what we use? Ultrasonic waves. How will you use that? Ultrasonic waves are allowed to pass students, ठीक है, through the metal block, ठीक है, and detectors are used to detect the transmitted waves. They are detected, ठीक है. Even if small defect is there, the ultrasound gets reflected back, indicating presence of flaw or defect. अब देखिए यहाँ पर ये अल्ट्रासाउंड वेव्स हैं, they are, this is our detector, they are going, अल्ट्रासाउंड वेव जा रही है, बट यहाँ पर देखिए कोई प्रॉब्लम है, ये फ्ला है, दिस इज अ फ्ला और a defect, ये defect है, this is a defect student. What happens here? You have seen immediately ultrasonic, they are coming back, reflected back from this point, because there is some crack here, it is coming back. So we can detect, students, we can detect if there is any crack or flaw in the metal blocks before we use them for constructing big buildings, bridges or machines. Ultrasound is reflected back from the defective locations inside the metal blocks. तो ये metal block use हो रहा था construction purpose के लिए. The important application which is used. There will be questions on applications of ultrasounds. Note कर लो. Let us see more. Further, student, ultrasonics are used to capture the images of the heart and features and problems associated with the heart, if any, for treatment purpose. This is called echocardiography. So are made to reflect from various part of the आपके heart वगैरह के लिए क्या है, medical, in medical they use what we call as echocardiography. Echo का मतलब reflected sound waves are coming back. Ultrasonic waves are made to reflect from various parts of the heart, ठीक है, and form image of the heart. They will form image of the heart. This is called echocardiography. In medical science it is used. Medical science uses this a lot. Note कर लो. More details you want, you can study more what is echocardiography. अब और आ गया important. What is this, students? बहुत important है. Ultrasound scans you have understood. In ultrasound scans क्या होते हैं, student? Ultrasonography, commonly used to get images of internal body organs such as liver. Medicinal science is using a lot of this ultrasounds. You want to get internal body organs image, liver, kidney, uterus. It helps doctor to diagnose and treat problems in the body of the patient. Ultrasound करवाना बहुत easy है. They go ultrasound test. The waves are made to travel through the body to the organ under consideration. They get reflected and these are converted to electrical signals which can be monitored on the screen. तो इसको क्या बोलते हैं? Ultrasound scans. Ultrasonography बहुत ज्यादा यूज हो रही है. Is used to observe growth of fetus inside the uterus. It is also used to monitor the abnormalities. तो fetus जो uterus में होता है उसको भी इससे ultrasonography की जाती है, और if any abnormalities are there then we can detect that. What else is happening? We already said ultrasound is used to clean machine parts located in places which are not accessible, like electronic component, internal parts, spiral parts, cleaning solution and waves. Because of high frequency, dust particles just fall out. अब एक और important question आ गया, ये sonar क्या होता? Sonar, what is sonar, students? Is a device that uses ultrasonics to measure distances which are practically impossible to measure. How do you measure the depth of a sea? Distance and direction of underwater objects. Underwater objects distance, how will you measure? So sonar comprises of ultrasound transmitter and detector fitted in a ship. तो शिप के अंदर क्या है? अल्ट्रासोनर, ये ट्रांसमीटर एंड डिटेक्टर है फिटेड इन द शिप. ट्रांसमीटर प्रोड्यूसेस अल्ट्रासाउंड वेव्स। ट्रांसमीटर क्या करेगा? अल्ट्रासाउंड वेव्स प्रोड्यूस करेगा। दे विल हिट द ऑब्जेक्ट, कम बैक, which travel hit the bottom of the ocean and return back and are detected. डिटेक्ट कर लेगा। उससे कितना क्या पता लगेगा? यू कैन मेजर द डेप्थ ऑफ द ओशन। Distance and direction of underwater objects. You can measure the distance and direction of underwater objects. ये सारी चीजें आप मेजर कर सकते हैं। तो सोनार इज अ डिवाइस। सोनार का मतलब क्या हुआ? सोनार स्टैंड्स फॉर, एस स्टैंड फॉर साउंड, सोनार साउंड, नेविगेशन, नेविगेशन, NA नेविगेशन, एंड रेंजिंग, रेंजिंग। तो साउंड, नेविगेशन एंड रेंजिंग। And ranging students that uses ultrasonic to measure the distance, direction and speed of underwater objects. How does sonar work? Sonar consists of a transmitter and a detector and it's installed in a boat or a ship. ये आपका शिप है। यहाँ पर आपने क्या क्या लगा रखा देख रहे हो? ये डिटेक्टर है और एक ट्रांसमीटर है, दो चीजें हैं। तो ट्रांसमीटर, ये मेरा ट्रांसमीटर है टी, और ये डिटेक्टर है। ट्रांसमीटर विल सेंड अल्ट्रासोनिक वेव्स। ये सी बेड है, दिस इज आवर सी बेड। अल्ट्रासोनिक वेव्स विल कम बैक रिफ्लेक्टेड बैक, ये रिफ्लेक्ट हो गई एंड डिटेक्टर विल कैच देम, डिटेक्टर विल कैच देम। दिस इज आवर वाटर सरफेस, ये बोट और शिप है, ठीक है। तो यहाँ अल्ट्रासोनिक सेंट बाय ट्रांसमीटर, रिसीव्ड बाय द डिटेक्टर। अल्ट्रासोनिक्स जो है सेंट किसने की? ठीक है, ट्रांसमीटर विल सेंड कर दी, और रिसीव का हुई डिटेक्टर। इससे व्हाट विल बी एबल टू मेजर द डिस्टेंस। द अबव मेथड इज कॉल्ड इको रेंजिंग। इसको क्या बोलते हैं? इको रेंजिंग, मतलब इको, रिफ्लेक्टेड साउंड वेव इज कमिंग बैक। इट इज यूज्ड टू डिटरमिन द डेप्थ ऑफ द सी, लोकेट अंडर वाटर हिल्स, वैली, सबमरीन, आइसबर्ग्स, sunken शिप एक्सेट्रा। कोई शिप सिंक हो चुके हैं उनके बारे में भी पता लग जाता है इसी मेथड से। तो टाइम टेकन फॉर अल्ट्रासाउंड टू रिटर्न टी and the speed of the ultrasound is V is now known. We know what is the speed of the sound, ultrasound wave which is going. तो distance क्या होता है? Speed क्या होती है? Speed is distance divided by time. तो अगर मेरा d distance है, t time है स्टूडेंट्स, ठीक है, तो ये मेरी स्पीड है v। तो डिस्टेंस कितना हुआ? v इंटू टी। तो ये डिस्टेंस मेरे को कब मिला? कि ये आपका ट्रांसमीटर है, ट्रांसमीटर, और ये आपका डिटेक्टर है, डिटेक्टर है, ये है ऑब्जेक्ट, ऑब्जेक्ट। तो कितना डिस्टेंस ट्रेवल किया? हाउ मच डिस्टेंस इज ट्रेवल्ड? सेम गॉन एंड कमिंग बैक।
यस सर।
तो जो फिर डिस्टेंस जो निकालना है, बिकॉज द वेव ट्रेवल्स ट्वाइस, वेव ट्रेवल्स ट्वाइस द डिस्टेंस फ्रॉम ट्रांसमीटर टू डिटेक्टर। तो इसका रिजल्ट क्या होता है फिर स्टूडेंट्स? देन व्हाट वी आर ट्राइंग टू से। तो फिर एक्चुअल में जो डेप्थ है वो कितनी हुई, डिस्टेंस कितना हुआ, ठीक है, then this will be divided by 2. We are dividing by 2. ठीक है, so the distance is given by this. So by using this method, by using sonar, is called echo ranging, we can locate the underwater hills, valleys, submarine, sunken, and depth of the sea can be determined. This is the depth of the sea by using this method. ठीक है, नोट कर लो. अब ये क्वेश्चन कह रहा है कि ए शिप सेंड्स आउट अल्ट्रासाउंडिक. शिप ने क्या किया स्टूडेंट? अल्ट्रासाउंड that returns from C-band and is detected after 3.42 seconds. If the speed of ultrasound is 1531 meter, what is the distance of the C-band from the ship? Okay, you got 2 minutes to answer the question, students. तो यहाँ पर क्या यूज हो रहा है स्टूडेंट? अल्ट्रासाउंड. ठीक है, that returns from seabed and is detected. What is the time of detection? 3.42 seconds. Speed of the ultrasound कितनी दे रखी है? How much? 1531 meter per second. तो स्पीड क्या होती है स्टूडेंट? डिस्टेंस बाय टाइम. तो डिस्टेंस कितना होता है स्टूडेंट? स्पीड इनटू टाइम. लेकिन वेव ट्रेवल्स हाउ मच डिस्टेंस? ट्वाइस द डिस्टेंस. तो फिर डी कितना आएगा? तो कितना आंसर आ रहा? व्हाट इज द आंसर?
Sir, 2618 meter.
टाइम कितना है? 3.42 सेकेंड डिवाइडेड बाई 2. कितना आया फिर?
2618 meter.
है
2618 meter.
2618
Yes, sir.
मीटर.
Yes, sir.
तो डेप्थ कितनी निकली हमारी? 2.618 मीटर. मतलब 2.6 किलोमीटर है उसका डेप्थ.
Yes, sir.
सी जो है तो काफी डीप होते हैं. सी इससे भी डीपर होते होंगे. कितना आ रहा? 2.618 किलोमीटर. सी बेड. ये शिप था, ये सी बेड है. अच्छा, 2.618 किलोमीटर आ गई. Another question is coming on the screen, students. What is the audible range of average human ear? कितनी है audible range?
20 hertz to 20 kilohertz.
That is the correct answer. What is the range of frequencies, student? Another question is on the screen associated with infrasound का क्या आंसर है? What is the answer for infrasound?
Less than 20 hertz.
Which animals can detect this?
Sir, rhinoceroses, whales, elephants.
What is the range of ultrasound?
More than 20 kilohertz.
What are the examples?
Bats, moths.
All right. You have seen, student, what is a hearing aid? People with hearing loss may need a hearing aid. You have seen a lot of people having a hearing aid. Hearing ko
Yes,
loss
sir.
with age also. With age, some people are hearing. Hearing aid is an electronic battery operated device. This receives sound through a microphone. Microphone सा लगा होता है. Microphone converts the sound wave to electrical signals. तो ये electrical signal में convert कर देता. These electrical signals are amplified by an amplifier. The amplified electrical signals are given to the speaker of the hearing aid. Speaker converts the amplified electrical signal to sound and sends to the ear for clear hearing. So sound energy is converted into electrical energy. You will see that. इसमें क्या हो रहा है? Sound waves are converted into electrical signals. Energies, we have already said, energies can be interconverted. Student, one form of energy can be converted into another. तो ये जो हमारा एग्जांपल था, ये किस चीज का एग्जांपल था स्टूडेंट की? Here sound energy is being converted into electrical. यहाँ पे क्या हो रहा? Sound energy getting into electrical conversions हो रही हैं. फिर इलेक्ट्रिकल एनर्जी इसमें चल रही है बैक टू द साउंड. तो इस तरह से ये ट्रांसमिशन हो रही है एनर्जी. So a lot of people are using hearing aids, are very common, which you already know about the hearing aids. And this is all science is about applications. How much applications we can apply and how successfully we use. That's very, very important. So we end up the session here. We will continue and meet you next time with some important questions on sound. And okay, then we'll meet you next time. Bye bye.
Thank you, sir.